Alright, in this clip we're going to be going over how to express integrals as Riemann sums. So to get us started, we're going to take a look at the formula that's going to guide the problem solving process. Okay, so go ahead and write this down. The formula is as follows. Um, so let's say we have a function that is continuous. If f of x is continuous on an interval ab, then we can write down the definite integral from a to b of f of x dx. We can write it as a Riemann sum. The Riemann sum is going to be the limit as the number of partitions or subintervals approach infinity of the sum from k equals 1 to n of the function evaluated at a plus the width of the subintervals, multiplied by k, and then this multiplied by the width of the subintervals, where delta x, the width of the subinterval, is given by the length of the interval divided by the number of intervals that you have. Now this formula can be written in terms of a, b, and k. Okay, so let's rewrite it in terms of just a, b, and k. If we write it in terms of a, b, and k, the Riemann sum is going to be the limit as n approaches infinity, basically the number of subintervals that you have, of the discrete sum from k equals 1 to n of the function evaluated at a plus. Now instead of writing delta x, the width of the subinterval, let me change my grouping into bracket here. So use bracket. So instead of writing delta x, we're going to use the b minus a over n equivalent. So plus b minus a over n, this entire thing multiplied by k, and then delta x will be another b minus a over n. So what this second formula helps you to see also the first one is we're going to be using b minus a over n twice in this formula. Okay? The first one goes into the function, and then the second one you will be multiplying the function by that. Alright, so let's go ahead and take a look at an example of this function in action. So the instructions are to write the given definite integral as a Riemann sum. So for number 1, let's say you have the integral from 1 to 5 of x to the third dx. Okay, so we're going to start off by rewriting the formula again. We're going to list the different components that we need, plug it into the formula, and we'll be in business. Okay, alright, so let's go ahead and write down the formula again. So the formula is as follows. The integral from a to b of a function f of x with respect to x can be written as the limit as the number of subintervals approach infinity of the discrete sum sigma from k equals 1 to the number of intervals of the function evaluated at a plus the width of the subinterval delta x times k multiplied by the width of each subinterval delta x, where delta x, the width of the subinterval, is the width of the interval divided by the number of subintervals that you have. Okay, so what do we need here? We just basically need a, b, um, yeah, a and b and what the function is, and then we should be good to go. So a is the lower limit of integration, which is 1. B is the upper limit, which is 5. And then we also need to know what the width of each subinterval is, delta x. Delta x is b minus a over n, as indicated here. So we're going to do compute 5 minus 1 divided by n. 5 minus 1 is 4 over n, and that's the width of the subinterval. And then don't forget the function under consideration is x to the third. Alright, so we're ready to apply this formula to the problem. So the integral from, where we're going from 1 to 5, the integral from 1 to 5 of x to the third dx, written as a Riemann sum, is the limit as n approaches infinity of the discrete sum from k equals 1 to n of the function evaluated at a plus delta x times k. A is 1 plus delta x is 4 over n. We're going to multiply that by k, and then we'll multiply that by delta x, which is 4 over n. So let's go ahead and simplify this and also evaluate. If we simplify, we'll have the limit as n approaches infinity of the sum from k equals 1 to n. The function will be evaluated at 1 plus 4k over n multiplied by 4 over n. Now to finish this off, we're going to evaluate this function at, the function that we're evaluating is x to the third. So we're going to be evaluating x to the third at 1 plus 4k over n. Okay? So finally, we're going to have the final answer, limit as n approaches infinity of delta k of the sum from k equals 1 to n. So all we're doing is we're taking this value right here, 1 plus 4k over n, and we're plugging it into this function. Okay? So that's what we're doing. So if we plug in this input into this function, all you're going to have is 1 plus 4k over n raised to the third power times 4 over n. And that, ladies and gentlemen, is your final answer. That is how you express the original integral using Riemann sums.